Next up, worksheet number 2. Equally easy as the first one is worksheet number 2. On this one, we're going to learn how to use the packet of directions called the procedures. Okay? And what I've got is a sample step written on here with little tags around it pointing out what stuff is. So when you read a step, you know what it's trying to tell you. Okay? So, procedures for Scotland Yard use the following format. We've got a number, explanation of what it is, possibly a location, and then directions. Okay? Now, starting off with the number. These are the numbers that match with a flow chart. So if I see number 5 on the flow chart, I would come to this direction in the procedures. Okay? Then I have something in parentheses. These parentheses can be very complicated, like this one. Test to separate insoluble hydroxide metals and excess ammonia. That's kind of the chemistry bigwig term of, hey, we're going to pull something out of there and make a solid out of it. Okay? It can also be very simple, like final test for Dr. Jack. So they can be very short, they can be very long. Third thing you might find, now notice I said the word might. If your step has a particular location that you have to go to, it would be written as the third thing. For example, we don't go outside anymore. I should have changed that on the handout before I gave it to you. We used to go outside for one of our steps in the old Aylen building. Now we have 4 different locations where you could be. You'll be assigned a station somewhere in the room. That's your general place to work. There's 12 of them all together. Then there are 3 specific places you could go. The big fume hood, the small fume hood, or the heating station, which is right back there behind a man underneath the whiteboard. Okay? That's where the heating station will be, and also centrifuging. So if it says, like this step this year has been changed to the small fume hood, if it says small fume hood, you know you're going to come and do your step over here. Okay? Now, then the step is usually broken into 2 parts. Part A, which is some sort of chemical process, and Part B, which is an if-then statement of where you're going to do, or what you're going to do next. Okay, so let's look at our first part here. I got a little A next to it. That's not always there, but it's just so you know where to start. To the liquid labeled step 5, add 10 drops of NH4Cl and stir thoroughly. Now add NH4OH dropwise until the solution is slightly basic, pH 9 or 10, dark green on the pH paper. Stir for 1 minute, then gently heat your test tube in boiling water for 3 minutes. Centrifuge the mixture even if you do not think there's a solid because it may be hard to see. Some of you maybe remember this step from 2 weeks ago. When we did the transition metals lab, that's what you did at the small fume hood. Remember a lot of you made the mistakes of I put 10 drops of both in? When that was wrong, they do 10 drops of NH4Cl and then make it basic. That's what you do at the small fume hood. Okay, so that's an example of the types of things you'll see. pH, evaporating dishes, using the centrifuge, heating in a boiling water bath, a million different things. All kinds of chemical type additions, etc. Okay? So that's what the first half, if you want to call it, of every step will have. Something for you to do chemically. Then the next part will always end with an if-then statement. Like this one. If you get a white gel, green-gray solid gel, or orange-brown solid, separate from the liquid and label the solid step 6. Separate it from the liquid, which means we're going to pour the liquid out, and now we have 2 test tubes with stuff. One with a solid, one with a liquid. Scotland Yard will not very often tell you to dump stuff out. You usually are saving darn near everything while you're doing it. So make sure you're not dumping stuff down the sink ever, and if you do discard stuff, it'll go in the waste container. And then any remaining liquid is labeled step 14. So if you get a solid, pour the liquid out, label it 14, keep the solid, and label it 6. Okay? Now, some special notes at the bottom. If a sentence at the end of the step is in bold, italicized print, then it's the final step to identify the unknown. If you get the proper result, for example, the end of step 11 states, if your solution turns a blood red color, then Ironside is guilty. Then you know who one of your criminals is. Whenever we see the bold italicized print, it's a final step. And that means you're doing something that could prove somebody guilty. Okay? Whether it's solids or liquids or flames or colors, there's something that you're looking for to decide if they're guilty or not. 2, if a sentence is underlined, then it's an important point that has to be followed for procedure to work correctly. There's also a lot of safety stuff underlined as well. Like bubbles will form during this experiment. Make sure they don't just splash on you. Or making sure you check to see if you have a solid. And if you don't, take it up to your teacher is one of the steps, etc. Then finally, steps with an asterisk are steps that do not require any chemical additions. There's no chemicals being added. They are usually processes for separating a solution into different test tubes. For example, there are 3 steps that have an asterisk by them. Step 9, Step 20, and Step 25 have a little asterisk here and in the definition or in the procedures. And what that means is no chemicals are being added. You're just separating your test tube. Like Step 20 says, take your test tube from Step 19 and separate it into 4 test tubes, and use it for each of those 4 tests. Okay? So when you see an asterisk, no chemicals should be added, so there will never be a chemical reaction. That's why when you see it's 25, there's no box below it. Okay? So if you see asterisk, no chemicals have been added. Okay, the kinds of questions that you'll see on this worksheet will ask you to read the directions. Don't expect to find answers on the flow chart for worksheet number 2. It'll tell you something like, let's look at our first one here. What chemical do you add in step 21? Well, to answer that, you grab your procedures, you turn to where step 21 is, and just read what it says and write it down. It says, to the test tube labeled step 21, add 2 mils of NH4SCN. So I would answer this, 2 mils of NH4SCN. Okay? That's what your first 9 questions will be like. Read the directions, find what they're looking for. And it'll be a mixture of things. It's not always the chemical. It can be what pH is it, how long do you heat it, stuff like that. Step 10, what is the purpose for the following steps? The purpose is what is written in parentheses at the beginning of the step. So whatever it says there, you're going to copy here. And then finally, number 12, you're going to be looking up the final tests for all the criminals so you get an idea of what they do when they're finished. The final step number is the last step you did before it says guilty. And the final observation is whatever it says you're looking for. Like on Ironside, it's blood red liquid. So you write down blood red for the final observation. Okay? Oh, one other thing. Number 11, on your handout, switch that to small fume hood. I forgot to switch outside. It should say small fume hood. What list of steps where you go, where you use the small fume hood control step. Okay, you have 2 worksheets to do. Here's my expectation. I'm expecting that you'll have them done about halfway through the period tomorrow. Okay? So you have the remainder of this class. You've got 25 minutes plus about 20 minutes tomorrow to get both worksheets done. Yes?
How do you know if something reacted or not in a step?
Okay, that's a great question. How do we know something reacted? If the symbol and the formula change, then it reacted. Like, let's say I was doing step 16 for calcium, okay? Above it, it was CaCO3, it was in a formula. Below it, it's something different, Ca. If it changes its formula, then something happened. If its formula stays the same, then nothing happened. Okay, like on, here, right here, step number 5. Nickel was Ni+2, and I go right here and it's still Ni+2, so it didn't change. So whatever I added in that step did nothing to it. Okay? So if the formula changes, then something happens. Usually a good indicator is if it's shaded to clear or clear to shaded. Other questions before I let you work on your own?
How do you list the reactant and the product for the reactant?
Whatever's in the box above and below.
So
For that.
just write the difference.
Yes?
Do you have to do the questions on worksheet number 1?